Hey everyone, welcome back to Daily Dose of Space. When we look up at the night sky, space can feel calm, distant, and almost peaceful. But the reality is very different. The universe is filled with places so extreme that a human wouldn't survive for more than a fraction of a second. Regions where atoms are torn apart, where radiation floods everything, and where the laws of physics are pushed to their absolute limits. Today, we're exploring the most dangerous places in the universe, based not on science fiction, but on real astrophysics. Let's start with one of the most violent objects ever discovered. Magnetars, the most extreme stars known. Magnetars are a rare type of neutron star, formed when a massive star collapses at the end of its life. They're already dangerous by default. A neutron star packs more mass than the Sun into a sphere about 20 kilometers wide. But magnetars take this to another level. Their magnetic fields are the strongest known in the universe, trillions of times stronger than Earth's magnetic field. If a magnetar passed halfway between the Earth and the Moon, it would erase all credit cards on the planet. At closer distances, it would literally distort atoms, ripping electrons away and breaking chemical bonds. Magnetars are also prone to sudden starquakes. When the crust of the star shifts, it releases massive bursts of gamma rays. In 2004, a magnetar flare inside our own galaxy briefly affected Earth's atmosphere from 50,000 light-years away. If a magnetar were close enough to Earth, its radiation would strip away the ozone layer and cause mass extinction. This isn't speculation. This is basic physics. Black hole accretion disks. Black holes themselves are dangerous, but the real threat lies around them. Surrounding many black holes is an accretion disk, a swirling ring of superheated gas and plasma falling inward. Inside these disks, temperatures reach millions of degrees. Matter is accelerated to near light speed. Friction and magnetic forces cause intense radiation across the electromagnetic spectrum. Any object entering an accretion disk would be torn apart long before reaching the event horizon. Near supermassive black holes, the radiation output can exceed that of entire galaxies. These systems are called active galactic nuclei, or quasars. The jets launched from these regions can extend for hundreds of thousands of light years, blasting charged particles into intergalactic space. Being anywhere near a quasar jet would be instantly lethal, not because of gravity, but because of radiation and particle bombardment. Ironically, black holes are not dangerous because they suck everything in, but because of the extreme environments they create around themselves. Gamma-ray burst zones. Gamma-ray bursts are the most powerful explosions since the Big Bang. They occur when massive stars collapse into black holes or when neutron stars collide. For a few seconds, a gamma-ray burst can release more energy than the Sun will emit over its entire lifetime. If one occurred close enough to Earth and was pointed in our direction, it could sterilize the planet. Gamma rays would destroy the ozone layer, trigger atmospheric chemistry changes, and expose the surface to lethal ultraviolet radiation. Scientists believe gamma-ray bursts may have caused at least one mass extinction in Earth's past. Fortunately, they are rare in our region of the galaxy, but across the universe, they remain one of the deadliest known phenomena. The centers of galaxy clusters. Galaxy clusters are the largest gravitational structures in the universe. At their centers lies something unexpected, extremely hot, diffuse gas called the intracluster medium. This gas reaches temperatures of tens of millions of degrees and emits powerful X-rays. Even though it's incredibly thin, the sheer scale makes it deadly. A spacecraft traveling through it would be bombarded by high-energy particles and radiation. The gravitational forces in galaxy cluster cores also warp space-time and accelerate galaxies to thousands of kilometers per second. These environments are chaotic, energetic, and hostile to anything resembling life. Cosmic radiation hotspots. Not all dangerous places are visible. Some of the most lethal regions in space are defined by radiation, not objects. Near supernova remnants, cosmic rays are accelerated to extreme energies. These particles travel close to the speed of light and can penetrate spacecraft, human tissue, and DNA. Extended exposure would cause severe radiation sickness, cancer, and cellular damage. Even astronauts aboard the International Space Station receive significantly more radiation than people on Earth. In deep space, without Earth's magnetic field, radiation becomes one of the greatest threats to human exploration. Why Earth is surprisingly safe. After all this, it's worth asking, why are we safe? Earth is protected by several layers of defense: a magnetic field, a thick atmosphere, and a stable position in the galaxy. We are far from gamma-ray burst hotspots. We orbit a quiet star. We live in a relatively calm region of the Milky Way. These conditions are not guaranteed elsewhere. The universe is not designed for life, but under the right circumstances, life can survive, which makes Earth far more special than we often realize. Space is beautiful, but it is also violent, extreme, and unforgiving. And yet, understanding these dangerous places helps us understand how the universe works and why our small corner of it matters so much. If you enjoyed this deep dive, subscribe for more space science explained clearly without hype. This was your daily dose of space. See you next time.